So let's get started. I'll give you an introduction to the course. The goal of today's training is to give you a good overview of the capabilities of FME Desktop. Due to the compressed timeline, we can't cover all of the capabilities, of course, but we're going to focus on the basic functionality, concepts, and terminology, and also give you resources so you can go and find additional information yourself. This is a relatively new training module. It covers some of the content from our more extensive Desktop Basic course, which we're offering next week. That's about a 10-hour course spread over 5 mornings. Whereas today, we're going to just give you just the basics, just the sort of essentials in 1 morning. As this is a newer course, we definitely welcome feedback to help us improve it. I'll be sending a feedback survey link at the end of training today and would really appreciate if you could fill that out to help us improve the course. As you can see, if you're looking at your manual, we've got 4 different sections today that we'll be covering. There's a first section called Getting Started, which will be an overall introduction to FME. Then we'll cover translations, which is our word for converting between formats. Transformations, which is where you're actually changing your data. And workflows, which is where we're going to go over slightly more complex procedures and how to organize your work in FME. The length will vary, but each section takes around half an hour to complete and will be a mix of lecture and demonstrations and then some hands-on exercises. We'll be taking a 10-minute break halfway through. And we will probably take until about noon Pacific, so about 3 hours to complete the course. Again, if you have any questions, please use the GoToWebinar questions panel. I'll just show this again because I think I had a bit of an issue with my screen earlier when I was showing it. You should be able to access the sample data on the computer. I'll show you where that's located. You can find that by clicking this your File Explorer down here in the taskbar, and then this PC, and then the C drive. And you should see right in your C drive, you've got a folder called FME Data 2019, and that contains all the sample data for today's course. Again, if you're not working on a virtual machine, please download the data from the course resource page and extract it to your C drive. I'll also point out within this folder, there's a workspaces folder. And this has a folder for each of our courses, one of which is today's Intro to Desktop. And this just contains starting and completed workspaces for all of the exercises we'll be doing today. So these are basically a way, if at any point you do get behind or want to see the quote unquote final answer to an exercise, you can open up these workspaces and that will allow you to see those. I'll be showing that again when we do the first exercise. So I'm going to go ahead and move on to the Getting Started section of today's training, and I'm going to chat out a link. I'll take one quick moment to see if we have any lingering questions. We do have a PDF version of the manual available. Liz, if you wouldn't mind maybe sending that out to chat, that would be helpful. Some people do prefer to work on a PDF. Okay, let's begin the first section here. The learning objectives for today's course, or for the section I should say, are after completing this unit, you should be able to describe FME and what it does, distinguish between the different products that Safe Software creates, FME Desktop, FME Server, and FME Cloud. And you should be able to open a workspace and run it. First of all, let's talk about what FME is. FME stands for Feature Manipulation Engine, though we've kind of dropped that full name and now really just refer to it as FME. And FME is the data integration platform with the best support for spatial data worldwide. We have a little introductory video you can watch later if you want in the manual. I'm not going to make you sit here and watch that right now, but you can check it out later if you want for sort of a nice overview of the software. Safe Software began in 1993 to tackle a problem that we were having here in British Columbia, where forest companies and the provincial government were trying to exchange maps but they were working in different formats, and it took a lot of manual work to share their data. Nobody was really happy with that solution, and so Safe Software was founded to address that problem by allowing the provincial government and the forestry companies to convert data back and forth between the formats. And since then, we've just been expanding our scope and adding more and more formats and ways to address data interoperability and data integration challenges. Some of you might have seen in 2017, The Economist made a rather interesting claim that the world's most valuable resource is no longer oil, but data. Organizations today have the ability to access a huge amount of data, but it's still a struggle to find ways to actually use that massive information to make decisions. And one of the central ways you can do that is by integrating your data together. We define data integration as bringing together data from disparate sources in a unified view to create a data set with both valuable and usable information. A lot of organizations today struggle with what you might have heard referred to as data silos, where data is blocked off in different departments or with different people or in legacy systems. And it's hard to get those systems to talk to one another. And that's really where FME comes in. FME is designed to allow organizations to maintain a lot of the infrastructure they already have, but allow them to share data between these formerly siloed off areas. And how we do that is displayed in a kind of general sense on this diagram. This is what your workspace is going to look like when you construct it. We integrate data by reading it in on the left-hand side of a workspace. So here, this could be sources of data, A and B. Can optionally use transformer tools to affect and change the structure or content of the data. And then you can write it out to an output location here shown as C. And the nice thing is about FME is that the formats of A, B, and C here can really be whatever we support. And we try to make it as easy as possible to work in different formats. Additionally, that data can have a spatial component. So you can be using GIS data or another kind of mapping data, and FME will handle that better than any other data integration tool. And finally, as you can see from the screenshot, we're using a graphical interface, so you don't have to do any coding. We do support allowing you to do some coding within workspaces if you want, but it's really designed so you don't have to write any code. FME works by using a centralized model, so we can add support for a new format by just plugging it into our core engine. And this allows us to support hundreds of file formats, including tabular data or spreadsheet data like Excel or CSV. We support structured data like XML or JSON. We can connect to many kinds of databases. And of course, we support a wide variety of spatial data for GIS, CAD, BIM, and many more. Because of the wide amount of data we support, we have customers in many industries, but some of our big ones are architecture, engineering, and construction, energy, federal and local government, telecommunications, and utilities. There's a few examples here at the bottom. I won't go into detail on any of these, but just to give you a quick blurb about how some customers are currently using FME. The Vancouver International Airport uses FME to help integrate their floor plans in a computer-aided design or CAD format into a new indoor mapping format, which is going to be used for navigation in Apple Maps. So travelers at the airport can actually navigate inside using Apple Maps. The Weather Network uses FME to provide real-time weather data from multiple sources. And Tetrad uses FME to help their customers choose sites for new retail locations. And we've got links to all of those customer stories in the manual if you want to check those out later. First component we'll talk about today is FME Workbench. This is really the heart, I guess, of the FME platform. It's an application for creating graphic-based solutions to data translation and transformation requirements and can handle geometry and attributes of spatial features. Take 1 second to introduce our mascot here, the FME lizard. He shows up in the manual, or she, not sure. She'll appear throughout the manual to give you some sort of tips. I'm not really going to cover those too much, but as you're reading, you might want to check those out for some little tips and tricks for using FME. At this point, it's probably a good idea to actually open up Workbench. We'll be using it in the next exercise, but when you first launch these virtual machines, the Workbench has to be licensed, so it could take a moment to start up. So let's go ahead and do that right now. If you're following along, you can go to the Windows Start menu, and then in your programs list, find FME Desktop, and click to expand that. And then you want to launch this one at the bottom here, FME Workbench 2019.0. So I'll go ahead and click that. And as I said, because this is the first time it's starting up, it'll have to get licensed, so it might take a moment to run, but you should see the splash screen come up and FME Desktop will begin to launch. In this next session here, what I'm just going to do is show you the different windows available in FME Workbench. So this is what Workbench looks like here. I'm going to click New here just so I have a blank space to show you some of the windows that are available in FME Workbench. I'm also just going to turn some of these on. You don't have to follow along here, just doing this so you'll be able to see what I'm working with. So this is what Workbench looks like. Let me go through the different areas here. So the main one here in the middle, which is blank right now, is called the canvas. This is where you will construct your workspace by adding objects, adding in files you want to read or transformers, ways you want to change your data. You've got your standard menu and toolbar up here, which has a lot of the commonly used procedures you might need to undertake. The top left section here is called the navigator, and this basically shows an outline view of your workspace. So objects you add onto the canvas will also be added onto your navigator, and it's just a slightly different way of organizing the view. Here it's sort of a list and nested list, and here you'll have a more visual spatial layout. Down in the bottom left, we have two windows which are tabbed. You can see you can switch back and forth by pressing these tabs here, and all of this you can customize, which we'll show later. But the parameter editor, when you have an object selected on the canvas, you can edit its parameters here. And the transformer gallery contains a drop-down list and a categorized list of all of the different transformers we use, which, as I mentioned, are these tools you can use to transform your data, to change it in some way. Similar to the ARC toolbox, if any of you are coming from using Esri products. Down here in the bottom of the window, we have two windows useful for checking your workspace as you build it. We've got a translation log. This will log everything that happens in your workspace. So if there's any errors or warnings, you'll be able to see those here. You'll be able to see if your translation was successful or not. And this will be saved locally as well. And then there's a new tab here, which is new for 2019. It's really useful. We'll be working with this quite a bit today, Visual Preview. This lets you quickly look at the data as you work with it. So if you add a data set to your canvas, you can click on it and look and inspect it down here, either a table or if it's spatial data, you can see a little map. So those are the sections of Workbench. There's a nice graphic in the manual if you need to refer. If you hear me say something, you're not sure where it's located, you can see that there. Now, before we get started with our first exercise, I do like to get some of the terminology out of the way. I realize I've been talking already at you for quite a little bit, but I think this is worth going over right now so that we're all on the same page. And this is a section where I'll talk about the components of FME Desktop. And I'll actually scroll down just to this image here, because I think this is a good way to organize this discussion. These are all the different components of FME Desktop. When you're using FME Desktop, in particular when you're using FME Workbench, what you're doing is building a workspace. So that's the top level of the hierarchy of objects in a workspace. It's really the entire definition of a data translation. You will also hear is called the .fmw file that you save. That's also called a workspace. The next level on the hierarchy is readers and writers. These are objects within a workspace that either read or write data. Generally, each format of data you want to read requires a different reader. For example, a workspace might contain a reader to read Esri shapefile data and another reader to read GE small world data. And then similarly, each output format requires a different writer. So you might have, for example, a writer to write an Autodesk AutoCAD DWG file, and also a writer to write to a Microsoft SQL Server table. And so as you can see from this diagram, workspaces can contain multiple readers and writers. The next level of the hierarchy are objects called feature types, and you can see those displayed here. This is what I would say sometimes trips up new users, so it's worth explaining in detail for a moment. I like to refer to feature types as logical groupings of data. And what this captures is how data is organized in an underlying format. And that's why we have to have this kind of general idea of feature types, because what is actually called will vary by format. So depending on the format, you would see feature types corresponding to a layer, a feature class, a category, a table, etc. So it's based on that underlying format, how that data is organized, and then what becomes a feature type in FME. And I'll show you an example of that in a moment. The final level of the hierarchy here is features. And these are really the smallest unit of data you work with in FME. And a feature will be an individual piece of information, so an individual piece of line work, a single polygon, a single point, or in a table, it'll be a single row. And FME is really a feature-based translation engine. And as you can see from this hierarchy, there will probably be multiple features within each feature type. And additionally, readers and writers can have a single or multiple feature types. So those are the terminology that we use to organize our thinking and our workspaces. Here's just some examples of how that would break down with some common formats. So if you're working with Excel, obviously there's the data set, which will be the XLS or XLSX file, also known as a workbook. You would add an Excel reader or writer to define how to read and write the data. A feature type would be a single sheet or a single table within an Excel workbook, and a feature would be a row in that sheet. If you're working with spatial data, so for example, an Esri geodatabase, you'd have the GDB file or folder, I guess, of a database would be your data set there. The reader or writer would be an Esri geodatabase reader or writer defining how to read or write. The feature type would be a single ArcGIS feature class or table within the geodatabase. And a feature would be a single geometric feature plus the attributes if it was spatial, or just a row in a table. And there's another breakdown here sort of visually to show you what that looks like in Excel. And finally, this is an example of what a workspace might look like that has multiple readers, writers, and transformers. So this might look a little overwhelming right now. You're looking at this and not quite sure what we're talking about, but really what this is supposed to illustrate is that you can have multiple readers, multiple writers, multiple feature types, multiple formats in a single workspace. And we'll look at that in a little bit more detail in the next exercise. Before we do that, let me just take a look at the questions here. We've got a question: if feature is synonymous with row or record and attribute is synonymous with a column. And I would say for the most part, that's true. That's definitely true if you're working with traditional spreadsheet or tabular data. So if you're reading in a CSV or an Excel file, each feature will be a row, each attribute will be a column. But the reason that we have our slightly more abstracted language is because we deal with many formats. So you might be dealing with a format like XML or JSON, which isn't a tabular format and is nested. And so then you have to kind of define within your workspace, how are you going to define a feature and attributes? And we have one quick question about database connections and reading and writing. It's basically as easy as adding a reader or writer, and then you can define a database connection with the credentials you want to connect with, and you can read and write in specific tables. We also have an array of transformers that let you do smaller kind of procedures, doing a SQL query on the database and just taking those features out, or doing sort of edits and updates for databases, we have kind of particular transformers for that, because obviously we can connect to a lot of databases. They don't function exactly like a standalone file would function though. Okay, so let's go ahead and move on and do our first exercise here. I'll go ahead and chat out a link to the first exercise if you want to catch up. And what we're going to do here in exercise 1.1 is jump into FME Desktop, and open up Workbench, and examine a workspace. You can see each of our exercises has this little table at the top that will give you kind of an idea of what we're up to. The thing I'll point out in particular is we have these start and end workspaces, and you can use these to get that kind of catch up or see the answer, quote unquote, to an exercise. And these just have the paths to those workspaces on your training machine. So let's get started here. We're going to check out an example here where we're going to open up the workspace that will actually be the final workspace you would complete at the end of today's training. And the example we're dealing with throughout today's training is an example of how a municipal government could use FME to summarize 311 call records. 311 is a special phone number used by municipalities in Canada and the US to manage non-emergency municipal service calls. So for example, if you noticed a pothole on your street, you could call 311 and report a pothole. And so we're going to use some data from the city of Vancouver where we've collected their call records, and we're going to sort of show how they could summarize and change the formats of that data using FME. So let's go ahead and open up a workspace. To do that, we're going to use a file browser. So open up your File Explorer here, and I'll start up at the top just so everyone can follow along. So to start off, you can click this PC, and then we're going to the C drive, FME Data 2019, Workspaces, Intro to Desktop, and we want the one up at the top there, Exercise 1.1-Begin. So make sure you find that workspace. It's also, as I said, it's shown here. The path is shown there in the Start Workspace section. And once you've found that, you can double click it. You will probably get prompted of how you want to open this file. Make sure you pick FME Workbench 2019.0. If you're working locally, make sure you get the right version of Workbench if you have it installed. And if you want, you can click to always use Workbench to open FMW files. And once you've done that, you can click OK, and a new window of Workbench will open up with our exercise. What I'm going to do now is actually split my screen. So I have Workbench on one side and the manual on the other. If you're working on a single monitor, you might want to do the same thing. To do that, I will find my Workbench window here, and I'm going to click and drag it and just move it over to the left. And then once I see this drop shadow rectangle, I'll let go to sort of dock it to the left-hand side of my screen. And then I'll be prompted to pick what I want on the right-hand side of my screen, and I'll pick my Chrome browser here so that I have my instructions on the right. Additionally, if you want to hide the menu bar, you can do that as well by clicking this menu button up in the top left of your manual. And that will allow us to kind of see both at the same time. So this is what a workspace looks like. You can kind of click and drag your sliders around to explore it. On the left-hand side, we've got objects that we are reading in, and you can see we've got little what are called annotations explaining what we're reading in. We are reading in at the top here a KML, which is a Google Earth or Google Maps format. That's going to have local planning areas in the city of Vancouver. We're reading in a CSV, which is a summary table of 311 data. And we're reading in the 311 data itself from XLS or Excel files that are actually stored in a zip file on the web. And that's one of the nice things about FME is you can point it to a URL to read in data, and you can point it to a zipped file, and it will automatically unzip it for you and start reading the data. Now, if you look at over on the right-hand side, we'll see what we're going to end up with. We're starting with those 3 data sets. What are we ending up with? We're ending up with a KML that includes that 311 data, so we're joining it together. And we're writing out to a CSV that has the 311 data with an edited schema. And then in the middle, we've got these blue objects, the transformers I mentioned earlier. And each one of these is sort of changing or editing our data in some way. So we're doing things like we're reading in the 311 data, we're removing missing values, we're cleaning up the attributes, we're fixing inconsistent data. And then we're using this feature joiner in a separate stream of features up here to join the summary table to the local area polygons. So let's go ahead and run this workspace. You can find your run button up in the top left here, this green play button. Once you find that, click it. You will be, oh, that's true, actually. Let's not click it yet. You can close that. We're going to turn that option off. So before you click run, click this drop down and uncheck this first option here, prompt for user parameters. That's on by default. We don't need it for this course, so you can just click that to turn it off. That lets you control sort of how to run the workspace, and we're not interested in using that feature right now. So once you've unchecked prompt for user parameters, now you can click the run button. Once you do, you'll see that your translation log starts to appear, and you can see lines in the log running. This is going to basically give you a play-by-play of the workspace of each thing that's happening. You'll also see, if you look on your canvas, these numbers along these feature connection lines are starting to increase. And that actually represents features, remember the smallest unit of data, moving from left to right across the canvas. So they start, they're being read in, that's counting up how many features we're reading. And then they'll just get sent one by one through the workspace, through these transformers, and in this case, getting written out here. And you'll notice this one's taking a little while, but we are reading tens of thousands of records from these Excel files, so tens of thousands of rows. And these are additionally being read from the web and from a zipped file. So that is making it take a little bit longer because we're reading from the web and actually extracting the data from a compressed format as we do so. So we'll let that run. It's going to take about a minute or so. And once it finishes up, you will see a message down here in your log window that says translation was successful. Should be the second to last row now in your log window. You'll also get what is called this unexpected input window. This one's appearing in this case because FME is expecting the KML features we're reading in to have these feature types called document and folder, which define metadata about the KML. We didn't bother to read those in because we don't need them. But FME is just making sure we know that they aren't being used. So it's essentially a sort of warning input, warning window. But we can ignore that safely and click OK. So now the translation should be complete for everyone. And we can actually inspect the output. We can click on this 311 local areas feature type here. So this is the KML data we had of local areas, but we've joined a summary table to it. Once you click that feature type to select it, you'll see some tooltips appear with options of what to do with the data. We're going to choose this one that has a folder and a little database icon. It says open containing folder when you mouse over it with a tooltip. Go ahead and click that. This is going to open the area where our data was written out. You'll see we wrote out a CSV file and a KML file. And what we're going to do, you can go ahead and follow along if you want. We're going to open up that 311 local areas file in Google Earth. Because of the virtual machine setup, we'll have to click through a couple things, but go ahead and double click that once you've found it. It should be in C FME Data 2019 output training. So this will open up Google Earth Pro, which is Google Earth's desktop application. And because of the virtual machine, we are going to have to click it through a few things, but it should work fine. Click OK for the first message. And then you'll get the startup tips, which we don't need, so you can click close. I'm also going to tell it not to show those again. Oh, it won't let me do that yet. We'll have to do this one first, so get another warning window. You can click yes for that. We're just going to switch the graphics mode, and we'll have to restart one time. So you should click OK and then yes, and then you should be able to start it again. If you don't feel like clicking or whatever, you can just view the data on my webcast if you prefer. So once this startup tips window opens, you can go ahead and close that. We don't need these tips. We're just interested in the data we've written out. So Google Earth should zoom in to the data we wrote out. I'm going to go ahead and maximize this so we get a better view. So this is these are polygons that came from that local planning regions data we read in. And if you are to click one now, you'll get a little bubble. And this bubble shows the data that's contained in the KML. And you can see here we've got a summary of 311 data. So what this is basically is it's saying what's the local area named. So this is the neighborhood known as Kitsilano in Vancouver. And then we have the different city departments. So public safety, engineering, and then the number of cases that were reported. I believe this is 2017 data. So the number of cases reported in that year in that local planning area. And so this represents sort of the output of the data integration workflow that we're going to develop today. So that's all we need to do for Google Earth. You might want to keep it open though, because we do have a quiz coming up, which is going to ask you to look at the data that we wrote out. So that is just a small demonstration, but you can see with relatively few objects here, what we're doing is we're going from a KML, a CSV, and an series of Excel files to a KML with some joined data. So we're taking non-spatial data and spatial data and combining them, which can be really powerful. And then we're also writing out a CSV with an edited schema. So if you do things like edit schemas for uploading data to databases or anything like that, FME is really good at that, and you can see that from this example. And we'll build that through the rest of the exercises today. So that wraps up our first section. I'll give you everyone a few minutes to answer some of these questions. You might need to look back into some of the sections we were talking about in order to answer those, including looking at the KML. So I'll give everyone a few moments to answer that. If you have any questions, please put them in the questions panel. I see a few people asking for the quiz, so I will put a link to that in the chat. So you should see a link to the chat in link to the quiz in the chat window now. I'm also seeing quite a few people are saying that their translation failed. The only way that would happen is if the data isn't where FME expects it to. The reason we use these virtual machines is because we actually have the file path to all of the data hard coded into the workspaces. And so it's looking for data in this C FME Data 2019 folder. So if you're working on a local machine and you downloaded the sample data, you have to ensure that FME Data 2019 is directly in the C drive, or the data won't, or the workspaces that we're using, these example ones, won't run properly. So again, if you're using the sample data on your own machine, make sure you extract it to the C drive here. Additionally, another problem could come up. Make sure you do have prompt for user parameters off. There shouldn't be a check here. So when you hit run, it will just run the workspace. And if you have those things set up, the workspace should run properly without any errors. If you are having problems, please do go into the questions panel and we'll help you out. Okay, I noticed that for some reason I must have missed a section here, and I didn't explain the different products that we use in here that we produce here at Safe Software. So I want to quickly talk about those. We produce FME Desktop, FME Server, and FME Cloud. FME Desktop is of which Workbench is a major component. That's what we're looking at today. That's what lets you build these transformation workflows using a drag and drop interface. That's FME Desktop. And that's the connect section of our platform. And then you can also automate. And you can automate your workflows by using FME Server, which lets you host your own server where you run workspaces, and you can run them on a schedule or in response to triggers like directories being updated or receiving an email. And then FME Cloud is just our FME Server product, but it's in a pay-as-you-go, fully hosted AWS cloud environment. So hopefully everyone had a few moments to complete those quizzes. Those are just for your own review purposes. We're not keeping track of the score or anything, so don't worry about that. Just a nice way to review some of the content we've talked about. I'm going to go ahead and move on to the next section here to keep us on track with time. If you do have questions, please pop them in the questions panel. Next section is on FME translations. Most people start using FME because they want to convert data from one format to another. They need to get their data from one system into another, so they want to do what we call a data translation, where you're converting data from one format to the other. We refer to translation rather than conversion to emphasize a goal of seamlessly letting data speak in the language, to use a phrase there, of a different format. So it's sort of quickly and easily getting your data in another format, but keeping all the information that you need. So in this unit, we're going to tackle a few things. We're going to actually create a workspace in Workbench. We're going to show you how to inspect your data. We'll explain a little bit the difference between a Workbench and Data Inspector. And we'll do some work with schema. We'll explain what schema is and show you how to edit and map schema using FME Workbench. And finally, for a sort of workflow section, we'll use a feature called feature caching. And we will also show you partial runs, so you can just run parts of your workspace as you go. Those are the learning objectives for this section. So let's start off by talking about how to make a workspace. You just opened one up and ran it. Now we'll show you how to actually create your own. In these sections in between exercises, I will be demoing things in Workbench. You don't have to follow along. I would just watch because I might go a little quickly, but then we'll do it together slower when we do the exercise. So for generating a workspace, that's the easiest way to get a workspace started. And you can do that by, on the Start menu, clicking on the Generate button here. This gives you the Generate Workspace dialog. This quickly lets you start a workspace by just defining one reader and one writer and pointing each of those at a specific file. You can always add more to the workspace later on. For the Generate Workspace dialog, you can start by selecting a format. You can click a drop down to see a list of commonly used formats. So we've got things like PostGIS database, CityGML files, JPEG if you're working with raster data, JSON for the web, all kinds of different things. Microsoft Excel if you work with a lot of Excel data. So you can do that drop down. You can also type. So if I wanted to add a CSV reader, I could just type in CSV, it will search for me. And then you can also hit more formats, which shows you the full reader gallery. So for all of the readers that we support. As you can see, several hundred. And then once you've selected a format, you have to provide a data set. And so you can just browse to find the data set you want to read in to start with. And it's the same process for the writer. You just define what format do you want to write out to, where do you want to write it. Once you have those filled in, you will click OK and you can generate a workspace, which will just quickly make a workspace for you. However, one thing to note, which we might run into later today, is that if you're reading in a data set with multiple feature types, again, remember that's going to correspond to a layer or a table, depending on what the format is. And whenever you read one of those in that has multiple feature types, you'll be prompted for which ones you want to add. So here we're adding in a geodatabase, for example, and it has several different layers: accessible parking, community centers, drinking fountains. And this is essentially FMA asking you, do you want to read all of these layers in, or are you only going to be working with a few? If you're only working with a few of them, you should only read those in because it's going to take time, processing power to read everything in. And so you'll see this becomes particularly important when, for example, if you add a database as a reader, you don't want to read in probably every table of the database. That would take a lot of time and memory. You just want to read in just what you need. So you might just pick a few tables. So that's the Generate Workspace dialog. Let's go ahead and do exercise 2.1, where we will walk through generating a workspace. I'll go ahead and chat out a link to that. You can also, if you're following along with the outline here, this is exercise 2.1 under the translations section. So we're going to start off by, we saw the end product already in exercise 1.1. We're going to rewind and go to how would you start to build that workflow. And in this case, the idea is that you just started to work at the digital and contact center services department of your local city, and they've said, oh, we have this 311 data in Excel, but we actually need it. Could you get it into a single CSV? Someone's requested just to have all of the CSV data or all of the Excel data into a single CSV. So could you do that for us? So we'll show you how to do that using FME. You can do this by starting FME Workbench. So make sure Workbench is open. I'll show you again where it is if you haven't had a chance to open it yet. It's under your Windows Start menu, and then FME Desktop 2019. You can expand that, and you're looking for FME Workbench 2019.0. And that will be your starting step. Make sure you have Workbench open. Once Workbench is open, you should see this Start tab, which has options for New, Generate, or Open. We're going to use the Generate Workspace button here, so go ahead and click that. Once you have the Generate Workspace dialog open, you can go ahead and fill it out following the table shown here. So what we'll do first is for the format for the reader, we're going to define Microsoft Excel. So you can type in Excel and it will search the formats, and you should find Microsoft Excel and click that once to select it as your format. Then you can specify the data set. I will go ahead and copy and paste this. This is a link to a zip file hosted on the web. And so you could think, in this case, this would probably be, this would probably be a zip file hosted on an open data site or a local web server, something like that. So that would be a URL you could put in there. And this is going to give us a zip file of 12 Excel files, which we're just going to read all of those in. Then for your writer, you're going to define the format as CSV. And then for the writer data set, of course, that doesn't exist yet. So we're just going to point it to the folder where we'd like to write out our data. So for format for writer, type in CSV and make sure you select CSV, comma, separated value. And then for the data set, we'll actually browse for that. So you can open a browser folder here by clicking that ellipses button. And we're looking for this file path here. So that will be this PC, C, FME Data 2019, output, training. And so once you found that, you can select that folder. So this is what your Generate Workspace should look like. I will point out, as you saw in that first exercise, reading from the web, of course, is going to be a little slower. So if you prefer, you could also put in a local file if you've downloaded the sample data or you're working on a virtual machine. We do have a local version of this zip file, and so you can use that instead if you prefer. I'm going to use the web data set, and I'll show you a trick for feature caching so I don't have to keep rereading it. But if you're not doing that, it might get a little slow. So you can make the call. You can use the web one or the local thing. I'm going to use a link URL there. So your Generate Workspace dialog should look like this. And once you have it set up like that, you can click OK. I'm going to go ahead and take a quick look at the questions here. So it definitely seems like a couple people are still having issues with the data. So let me just reiterate. If you are on a virtual machine, all the data should be in FME Data 2019. If you're not working on a local machine, please download the sample data from the course resources page. We've sent out the link in the chat. And then extract it so it's in your C drive, so the path will be the same. You want C FME Data 2019 to be the path. Then that will match all the instructions in the manual and make everything easy for you. I guess if you prefer, you could put FME data wherever you want and then navigate to it. Just know that the file paths then in the training obviously won't be reflective of where the data is on your machine. So this is what you should have when the workspace is successfully generated. You've got automatically you've added a one reader feature type and one writer feature type, and you've simply connected them, right? So that's basically the simplest version of a workspace. You're reading in one data set in one format, and you're writing it out in another. You can expand the list of attributes by clicking the arrow icon on each object. So here we've got that. These are the Excel files we're reading in. If you click this arrow here, that will expand the list of attributes. So these are all of the attributes attached to each feature. So again, remember, this is a feature type, it's Excel data. So each feature type here is going to be a table, and each attribute there would be a column basically in the Excel file. So we've got, these are 311 call records. So we've got basically time as one of the a series of attributes here. So when the call was placed, which department it affected, which division that department's in, what type of case was it, and then we've got some spatial data, well, non-coordinate spatial data here of where it was actually located. So you might notice if you expanded this, you can put that, toggle that on and off to see the attributes. You might have noticed now that we've expanded it, this reader feature type's rectangle that was surrounding it doesn't quite cover it anymore. This is called a bookmark, and it's basically a way of organizing your workspace so it's easier to look at and figure out where things are. And so I'll just show you how to expand that. You can click and drag to expand this so that it fits the new expanded feature type with the attributes if you want, like that. And that's not really required, it just keeps your workspace a little bit tidier. So now your reader feature type should look like that. You've expanded your list of attributes and the bookmark to fit it. And now let's go ahead and do the same thing for the writer. So I'm going to scroll over here. I'm going to expand my list of attributes. You'll see they're the same, right? Because by default, generate workspace, it just assumes you want to take in all the data from one format and just write it out to a different format, keep everything the same. So all of the attributes are going to be maintained. If there were, for example, restrictions on not having underscores or something, then FME would try to adjust for that based on the format. And so I've expanded my list of attributes. I'm now also just going to click and drag to expand my bookmark to keep that fully contained. So my workspace looks like this. If you want, you can also move these a little closer together. By default, they're kind of far. It's a little hard on one screen. So I'm going to click and drag where it says writer feature types and just move that over to the left a little bit. And you can also zoom in and out using this zoom up here. So I'm going to do that so we can see a little bit more of the workspace. So that's just a basic workspace, right? Reading in, writing out, same data, different format. I'm going to go ahead and save that by going to File, Save. And so again, this is just saving the workspace. It doesn't save any of the data. It's saving an FMW file, which as you can see are quite small. These are all about 40 kilobytes. And this is just saving the definition for the translation. So what you're reading in, what you're doing to it, where you're writing out, where things are located on the canvas, but it doesn't save any of the underlying data. You can save your workspaces today wherever you wish. I'm going to just save them in the root workspaces folder here because there aren't any others in there, but you can make a new one if you want, or you can really do whatever you want with it, just as long as it's somewhere you'll remember. And I'm just going to call mine exercise 2.1 and click save. Now that I've saved it, I will go ahead and run the workspace. So again, make sure you have prompt for user parameters turned off, and then hit the run button. And assuming your data is all in the C drive, the translation should be successful. And you'll get a translation log result, something like this, which you can see will do things like break down the number of features that were written, the number of features that were read, and if the translation was successful, how long it took, those sort of things. Before I do step 8 here, I'm just going to take a quick look at the questions, see how everyone's doing. Yeah, looks like everyone's doing okay there. One question, if you could have 2 workspaces open at the same time. You can, but you can't have them open in the same window of Workbench. So if you did want to have more than one workspace open at once, you can just launch another instance of Workbench. So once your translation has run successfully, you can find where that data went. So for step 8, we're going to locate the output. You can do that by clicking on your writer feature type and clicking Open Containing Folder. Remember that button we just used from exercise 1.1. We're going to use that again. And this will just take you to the directory that you wrote your data. And so you should see this new CSV file that has kind of an ugly name. We haven't renamed it yet. And we can open that up. If you want to, you can open it with OpenOffice, which is installed on these computers, but I'm going to just right-click it and do edit with Notepad++. Since it's a CSV file, it's really basic. It's just comma-separated values. Looking at it with Notepad will be fine to ensure that our data is in the right shape. So I'll do that. And you should see something like this, right? So you have your header column with each column name with comma delimited, and then all the values comma delimited with each row being a new line. So that's a very basic translation, right? We went from Excel and we came up with this CSV output. In the next exercise, we're going to cover how to actually inspect that data using FME rather than an external program. So let's move on to the next section, inspecting data. FME Desktop consists of FME Workbench, where you build the workflows, and FME Data Inspector, where you can inspect the data you're working with. There's also a number of smaller utilities, but we're not going to talk about those today. You can also inspect data from within Workbench using the visual preview window, which I mentioned earlier. That's new for 2019. In this course, we are actually primarily going to be using visual preview, but for the next exercise, we will show you data inspector, so you just have an idea of how that works. Let's talk a little bit about the components of visual preview. Remember, again, that's a window that will appear down here in the bottom left. I'll actually open it up here just to show you what it looks like. We'll actually do this together in the next exercise, but you'll have visual preview down here to view data within Workbench. Visual preview is an embedded version of FME Data Inspector. So they're basically the same. There's a few extra features you get if you use FME Data Inspector. That launches as its own separate application, its own window, whereas visual preview is directly within Workbench. So visual preview is good for quickly looking at things as you build a workspace to make sure that the data looks how you expect it to. Whereas data inspector is a bit better if you really need to dig into data, or if you have some big 3D data and you want a full screen view, you might want to use data inspector. You can view features in visual preview in a few ways. So one of them would be if you have a reader feature type, so your source data, you can right click it and go view source data, and that will open it in visual preview. There's also a tooltip icon that does the same thing. So here we have view source data. You have the same for view written data as well. So if I mouse over that, you see you've got a view written data tooltip icon there. Another way you can do it, we'll talk about this in the next section, is if you have a feature cache. So you can see this little green magnifying glass there, that represents a feature cache. So data will be cached at each step of a translation. If you have an object, a feature type or a transformer with a feature cache on it, if you click to select it, that will display it in Visual Preview. And finally, you can drag and drop data onto the Visual Preview pane to inspect it. So just as an example, if I have some parks data maybe that I wanted to take a look at. This is a map info tab file. I could drag that over to Visual Preview and it would just prompt me what format is this, and then I can display that in Visual Preview as well. So those are how you can view data in Visual Preview. Talk about some of the major components. You have options on the left-hand side of Visual Preview here that control how the pane works. First of all, you have options. This one at the top is toggle automatic inspection on selection, and that's an on-off toggle. By default, it's on, which is good because that means if we click on something that has a feature cache, we'll automatically view it down here. So I would usually keep that on. Maybe if you're working with really heavy data and you don't want it to be taking up processing power every time you click on something, then you might turn that off. There's also this Open in Data Inspector button, which will open the data you're looking at in Data Inspector, which is an external program, right? So we'll use that later on. Those are the two kind of options buttons. And then you have these 4 buttons in the middle here, which toggle different sections of Visual Preview on and off. So right now I have my table view on, which will show my data in a tabular view, and I can turn that off, right? Toggle that on and off like that. There's this graphics window view. This is tabular data, so there's no geometry, so it's not displaying anything. But if I did have spatial data, like this example in the manual, that would be shown here. The graphics view comes with a number of tools, so you can pan or zoom in and out with your data. And again, I can toggle that on and off. There's a display control window here. This will display all the feature types that or all the data sets that I'm inspecting. If I have multiple, they'll all show up and you can toggle them on and off. It will give you a number of feature counts that are displayed there. And so you can see if you have both your display control and your graphics window enabled, that kind of mimics the functionality of a lot of GISs, right? Where you have your layers displayed on one side and then your map view on the right here. It's important to notice though that Visual Preview and Data Inspector aren't standalone GIS or mapping applications. They're really just designed to let you inspect data. You can't edit data or do anything kind of more complicated. You can't really do cartographic output within Data Inspector, so that's important to know. And then finally, we have a feature information window. So if I, for example, go into my table and I select one of these features, if I turn the feature information window on, this just gives everything FME knows about that feature. So what feature type it's from, all of its attributes, and if it had geometry, it would also give you all of the geometry, all the coordinates of vertices and that sort of thing. So that's if you really need to drill down and figure out something about a feature, you can use feature information window. So those are all the components of Visual Preview. I'm going to go ahead and open up Data Inspector to show you what that looks like as well. So we'll be doing this in the next exercise, so you don't have to follow along here. I'm just going to go to FME Desktop and open up Data Inspector. We'll start without any data. I'm going to make this full screen and inspect some data here. So I'll open up and let's maybe take a look at that parks data I was just looking at earlier. So I'm going to add that to my data inspector. And so you can already see that basically all of the components of Data Inspector are available in Visual Preview. So you've got this would be the equivalent of the graphics window where you're displaying the spatial data. These are parks in Vancouver. They look a little bit without context right now because we haven't added a background map. We'll do that later. On the left, you've got a display control window, right? You can toggle these layers on and off. You can move their order. You've got your table view. If you select objects in the table, they'll also be selected in the view window. And the opposite works as well. If I select an object on the view window, it will be selected in the table. And you've got your feature information window with all of the detailed information. Toolbar with all your common procedures. And this is where there are just a few extra features in Data Inspector that aren't available in Visual Preview. Not many, though. So that's the basics there for Data Inspector. Here's a graphic if you want to refer to what the different windows are, what they're called. And there's a short list of differences between Visual Preview and Data Inspector. The primary difference is that in Data Inspector, you can open additional views. So if you see here, I've got a tab with view 1. You can add more views with other data in them. So you can have sort of a tabbed section of data there. And you can add data to be displayed on top. That's a little bit different. That Visual Preview doesn't work in that way. But besides that, they function pretty similarly. Next up, we've got exercise 2.2, basic data inspection. So let's figure out how Data Inspector works by inspecting some data. I will chat out a link to this section. So we will launch Data Inspector first. Let me close the one I have open already. And to do that for step 1, everyone please go to your Windows Start menu, FME Desktop, and we want to select FME Data Inspector 2019.0. So once you've found that, go ahead and click it to launch Data Inspector. I'm going to go ahead and do the same thing where I dock this to the left-hand side of my screen by clicking and dragging it over there. For step 2, what we're going to do is just open a data set in FME Data Inspector. To do that, you can click the Open button on the toolbar, and you'll see a rather familiar dialog. This basically looks like half of Generate Workspace, because really what we're doing is we're adding a reader. So what you want to look for here in Format, you can type in KML, and you should see Google KML come up as one of the options in the search. Go ahead and click to select that. And we're going to read in those local areas that we'll be working with to view those. So for dataset, click the ellipses button to browse. And you want to go to C, FME Data 2019, Data, Boundaries, and you want this local areas.kml file. So again, C, FME Data 2019, Data, Boundaries, Local Areas. Once you've found that, click Open. And your dialog should look like this. Google KML, and then the path. If you want as well, if you're working on a virtual machine or you have the data in the right place, you can always just copy and paste these file paths as well to make sure you get them correct. Once you've done that, click OK, and that will add the data to Data Inspector. And you should see the local areas appear. Notice that we actually did read in 3 feature types here. We've got the local areas region, which is the actual polygons. And we have those document and folder feature types I mentioned earlier, which are really just metadata. By default down here in our table view, we are actually viewing one of those metadata tables that is displayed first alphabetically, so it showed up in the table view. If you click down here where it says local areas OGC KML document, you can see this is how you can actually choose which table to look at. We want to look at the table for local areas region instead, which is the polygons, the spatial data there. So click that. That'll open up a new tab in your table view. This is also different than Visual Preview. You can't have tabs in Visual Preview. And this will just show you the tabular view of your data there. So these are all the attributes associated with each polygon. So if I click one, this is the Arbutus Ridge local planning area. It's selected there. So again, this is going to be useful if you want to know something more about a particular area on your map or you're troubleshooting and need to find out what's going wrong. You can use the table view and the view window here to drill down into your data. We just use the Open Dataset tool, which opens up a new view with the data. You can also use the Add Dataset tool to add a data to an existing view. So if I use Open right now, it would open up view 2 and start a new view. If I did Add, it will add it to view 1. So let's click Add. We're gonna add a CSV reader. So type in CSV for your format. And then for the reader data set, you can click the ellipses button to browse. And we're actually going to read in the data we just wrote out earlier. So instead of viewing it in Notepad++, we'll actually view it in Data Inspector. So to find that, let's go to FME Data 2018, Output, Training, and you want this rather long file name here, CA18COV1, service request loca, and then it got cut off, I think. So once you have that, click Open, and that will add that as the data set to add. So you should have that file path as the data set and the format is CSV. Once you have that ready, click OK. And again, this will add this to the existing view. So now we have another object here, another feature type in our display control window. Doesn't change the view on the map because this is just a table. It doesn't have any spatial data. But we can view the table by clicking on that drop down again and choosing the one at the top now, that CSV file. And now we can view the table of that. And so this is what those 3-on-1 call reports look like, right? We've got some time attributes, department, division, case type, pothole repair, etc. So that's good. We've seen the data we're working with here, one of the data sets we'll use later. But right now, this doesn't look very good. It looks kind of like Vancouver might be an island, right? It's just empty polygons. You don't have any point of reference for what we're actually looking at. So what we'll do is add a background map so we can get some context for our data. To do that, you can find add a background map in your toolbar. It might not be showing up if you've got your windows split like me. If that's the case, you can find this little expander button and click that to see the rest of the toolbar. And you're looking for this add a background map button here. Once you find that, and you can click it, you'll get this add background map dialog. We're going to click that source dropdown, and that will give you all the different sources of background maps you can use. You can see we support quite a lot, ArcGIS Online, here, Mapbox, MapQuest, Bing, etc. Most of those require you to have your own server or a subscription, so we're actually just going to use a free one, which is Stamen Maps. So go ahead and select that. You can call it whatever you want. I'll leave the default. And then just click the ellipses for map list. This will load the available layers from the background map service. And we're going to select the one called terrain. So that'll be right at the top. You can try the other ones if you want. They're just a little wacky. Terrain is a little more useful. So once you have terrain ready, click OK. And so you should have this set up for your add a background map. You're looking at the source is Stamen Maps and the map list is terrain. Once you have that, click Save. And now the background map will be loaded. It might take a moment. It's going to be kind of pulling this from the web, but you should see it appear. It shows up in your display control window at the bottom. We've got a little attribution here because this is Creative Commons, and you can see now we've got a background map loaded in. So obviously these are really useful, right? You can see now this is the city of Richmond, city of Vancouver. If I zoom in more, it's going to update. It has a couple different zoom levels, so I'll actually get to see street names, city names, things like that. So it actually provides context for the data we're working with. And I'm zooming in and out here just using the middle mouse wheel, scrolling up and down. You can also use your pan tool to pan around, zoom in, zoom out, etc. And I often also use this zoom extents button to zoom back out. So that'll be familiar for those of you who have used GIS systems before. If not, you might need to take a moment to play around with that to figure out how that works. Okay, congrats. That's the exercise 2.2 completed. If you want to be able to inspect data at every point in the translation, you can use run with feature caching, which is on by default for 2019. This saves a cache of the data at each stage of the translation, which is indicated by that magnifying glass icon I showed earlier. I'll switch back to Workbench to show you that, right? These little green magnifying glasses, those are feature caches. This is really useful for workspace testing. You can quickly build and check at each step, but it does significantly slow down your workspace because you're having to save and record all the data at each stage. So it should only be turned on when you're developing your workspace. And you can expect data at this point by simply clicking on the icon. So if you click on this icon, then that data will be displayed in Visual Preview. Partial runs are when only one section of a workspace executes, and this can be really helpful to isolate problems and quickly build out sections of your workspace, testing as you go. When you have feature caching enabled, you have the option to run the workspace to or from any given point instead of running the whole workspace all at once every time. And the workspace will just use the cache data to skip having to redo sections you are confident are working. If you click a object on your canvas, you'll see these green arrows appear, and these give you options for how to run your workspace. So you can do run just this for readers, which has a single dot, and that will just run that cache and refresh that cache. You can see the objects that you're going to run are highlighted in green when you hover over these icons. You can also do run from this, which will run from that. If it has a cache, it'll use that cache and then run on the rest of the workspace down the line. And if you select an object later down the path, you'll have the object run to this. And so that will run from the most recent green cache to the object you have selected. You can see as well in the manual, I can't really show it on here right now, but you can see in the manual, sometimes your caches will turn yellow, and these are known as stale caches, and that means you've made a change in your workspace parameters, so that cache might not accurately reflect what would happen if you were to run the workspace now. So in this case, if you had caches here and then you made a change to the area calculator, maybe you changed how you were calculating area of these objects, then that cache and all of the later caches would turn yellow, indicating that they're stale. You can still inspect them. They just won't be used for partial runs, and they might not reflect accurately what's going to be happening in your workspace. So basically, right, you can use run from this, run to this, and you can just run little sections of your workspace, and then you can use Visual Preview to quickly check, does this look like what I want? If not, make a change, run it again, check it, and move on. So let's go ahead and do exercise 2.3 to work with feature caching. Make sure you have Workbench up and running. You should have the workspace from exercise 2.2 open, so you should have your reader and your writer. You should also have a cache already on your reader feature type here. If you don't have that ready, then you should open the start workspace. Actually notice that, I apologize, that's the wrong file path there. It will be the same after the FME Data section there. That should be FME Data 2019. Everything else will be the same. So let me just put that in I'll put that in chat, what that actually should say. So it should be a path like that if you want to access the beginning workspace. And again, you can just use those to kind of catch up to get to this stage of the workspace. Okay, so everyone should have this on their screen now. First step is to make sure feature caching is on. You can click the little drop down next to run to see your run options. You can see you also have some options with feature caching here as well. And you should have feature caching enabled. So you should have a check mark next to enable feature caching. That's going to be your default option when you start Workbench. If you haven't already run your workspace, make sure you do that. But if you have run it from a previous exercise, you should see, I'll zoom in a little bit here, should see that green feature cache displayed on your reader feature type. If you click that, that'll display the data at that point in the translation, which in this case is identical to the data you're reading. Let's use partial runs to just run part of the workspace. If you click your reader feature type and then mouse over your options, you'll see, I should zoom out a little bit, you'll see the difference between these two options. So run just this, again, just the green object is highlighted, only this would be recached. Whereas run from this, it will use, if this has a cache, it'll use it. If not, it will run it again. And then it will run to that next section and run that as well. And finally, you can select your writer feature type, and you only have one option here because it's the end of the workspace, run to this. That will go back and look for the most recent cache and run to it. So you can see it's finding that cache on the previous section, the reader feature type there, because the whole reader feature type isn't highlighted. It'll be using that cache. Now, of course, in this specific scenario, these tools are of limited use because we only have two objects, so we're not really too concerned about partial runs, but I like to show this nice and early because we're going to be using it now for the rest of the day. So if you don't already have a feature type or a cache here, make sure you click run just this and get a cache on your feature type there. It might take a little bit if you're reading from the web, but once you have it, you can inspect your data in the visual preview window. So make sure you have that open down here. And then I'll show you a little way you can kind of quickly look at your data, see if you can identify any problems with it. So column headers here, of course, contain the names of each attribute. If you right click the context menu, you get a bunch of options for sorting. Can sort alphabetically, numerically, or actually new for 2019, naturally, where FME will determine or guess depending the type and try to sort according to that. Ultimately, our goal here is to report on 311 calls by local planning area, right? So we can join those together. You can see right now we've got a single record for each call. We want to kind of transform our table so we have a single record for each local area and we report the number of calls, do a summary table. And so to get there, we want to make sure all of these call data, all the call data that we're using, we want that to have a local planning area value. And so if you scroll over, you'll see we do have a local area attribute, which corresponds to those local areas we were looking at in Data Inspector. But some of our data has a missing local area. So this one right here, for example, doesn't have a local area associated with it because the reporting didn't enter in where the location was. So let's figure out how much of our data that might be a problem for by right-clicking local area and sort alphabetical ascending. This will sort our data alphabetically, and you can see we have quite a lot of missing objects here, and you can scroll down to sort of inspect those. And if you were to scroll down and inspect all of them, you would find there are 4,122 features with missing values for local area out of, if you look down here, about 97,000. If you took the time to manually inspect your data, you would find a few other kinds of problems. Some of the records don't have street addresses, and so they don't have a local area, so we found that. There's also another issue, which is that some rows just have fully missing data, which if you look at it is actually, there's 2 months or 2 features between each month of records with missing data. So that's a problem. We've got some missing data there. We're gonna have to filter that out. We don't want that to affect our workflow. And then if you have a keen eye for data problems, you might have noticed some other issues, which is the naming convention for local area. Two of the area names have a problem where they either do or do not have a hyphen. So we have Dunbar space Southlands, and we have Dunbar dash Southlands, and then we have Arbutus space Ridge and Arbutus dash Ridge. And that's going to be an issue for data quality. We need to make sure we have a consistent naming convention. So we'll have to fix that when we edit the schema. You can verify this by typing in your search window down here. So if I select for where it says any column, if you select instead local area, This is going to let us search in that local area column. If I type in just Arbutus without a dash, I get 2,236 features. You can see that there. If I add a dash, I get 116. So 116 of these have a dash. The rest of those 2,000 don't. And you can see the same issue with Dunbar. Has about 4,000 with a dash, has about 157. So that's the sort of problem we'll have to address in a later exercise. And this is just showing you how you can use sorting and searching to, at a kind of general level, inspect your data and look for problems. Of course, FME has a lot of really powerful ways to do that in a more systematic and automatic way, but these are just kind of a starting step of how you can interact with and inspect your data. So congrats, that's that exercise done. Hopefully you have a bit of an idea now of how to use visual preview and feature caching to inspect your data. Let's talk about schema and data model. Schema is the formal definition of a dataset's structure. It consists of things like layer names, attribute types, allowed geometries, and other rules or settings that define or restrict the data. This is an example of how you might define a schema in a table. So maybe, for example, this is an Excel workbook of business data. So it might be that you're defining sheets, columns, and types, right? And that's going to define your schema for you. So you have a sheet called customers, which will have name, address, phone, account number, branch ID, columns. And then types of those will be string, integers. And then you might have another sheet called locations that has different columns with different types. So that's basically how you're defining a schema. It's sort of the makeup of the data. In FME, schema is represented on the canvas. You have your feature types on the left and on the right, and they have their associated attributes. When you're first creating a workspace, for example, using generate workspace, you basically just copy over the source schema to the destination schema so they'll match. You can open the properties of reader feature types to see more detail on their schema. So for example, if I go over to the reader feature type we have here and open it up, you can view some details of the schema. So things like the sheet name are displayed here. And if I go to the user attributes tab, this is where all the attributes are displayed. So their names, their types, widths, and precisions. Notice here, I can't edit any of this. I can't change the reader schema because that data is already written, it already exists. I don't get to change it here in FME. I can just view it. And you can do the same thing for your writer feature type. You can just double click one of those to open up these parameters. But here, these are editable. So I have the CSV file name. I can change the name of the file name here. And I can edit my user attributes. So I could do things like, maybe I don't want underscores in my data, which is probably a bad idea for CSV, but anyway, you could remove those. And you can change the type. You can add new attributes or remove them. Oops, remove them. So things like that, you can basically edit the schema however you wish. So let's say I did edit it. I changed case type, got rid of that underscore. If I click OK, now you can see on my writer feature type here, I've got a new attribute called case type with a space instead of an underscore. So I've changed the feature type schema to be what I want here. That looks good, but a bit of an issue. I've got a red port here, which means that these attributes are no longer connected. So the data that's contained in the case underscore type attribute is no longer going to this one because it doesn't match. So I've edited the schema, but now I have to do what's called schema mapping, where I connect the reader schema to the writer schema to ensure that everything goes to the right place. So you can edit and map the schema however you want in FME. Just notice when you edit a schema, that will probably break the mapping if you're doing it this way. There are many ways to do it in FME, and in this case, if you're just editing it on the feature type, that's going to break the connection, and you're going to have to change. You're going to have to change how that works. You're going to have to map it. So let's look at schema editing and mapping here in exercise 2.4. I will chat out a link to that. Again, if you're behind, go ahead and open up the starting workspace here at that path, and that will catch you up to where we are currently. So now that you've created a workspace to translate the 311 data to CSV, the department has requested actually some changes to the schema. They want to remove those underscores from the attributes that have it, and they want to add in a date attribute. So we can use a transformer to make these changes to the schema. As I said, there's a lot of different ways you can change your schema in FME. We're going to show you one way. This reflects a larger point about the product, which is there's a lot of ways to do something in FME. Some ways can be faster, but it really depends on how you build it, what your purpose is, and that sort of thing. So we're just going to show you one way to change the schema here. It's one that we would recommend as being pretty good. Before we edit the attributes, let's actually change the feature type and the file name. So to do that, we're going to rename a feature type. Currently, the writer schema just matches the reader, so it just mirrored it. That's what happens when you do generate workspace, but that isn't a very nice file name, so let's change that. I'm going to double click. Everyone can follow along now. Double click the writer feature type to open up the parameters. You can also do this in the parameter editor window over here, but I prefer to just do it in a dialog. It's a bit bigger. So find where it says CSV file name, select that. We're going to get rid of that, and we're going to replace it with 311-requests. A little simpler. And so now, because we've changed that, it's going to update on the canvas, and it's also going to name the file name 311-requests.csv, because you can see it says file name there, right? Okay, so once you've done that, we've changed the name of our feature type. Let's go to the user attributes tab by clicking here. And then you'll see your list of attributes. And this is editable, of course. So let's make the changes that have been requested. They're outlined in this table in the exercise here. Basically, you're removing all the underscores from attribute names, and we're adding a new attribute called date. So to edit the names, you can simply just click in the cell where they are under the name column and make your edits. I'm just using backspace to get rid of the underscore and then hitting enter to confirm. So I've changed those. You can see their little port now is changed to gray. And then I'm going to add an attribute. You can add an attribute by hitting the plus button to insert a row, or you can just click in this blank last row. And so I've clicked in the name column in the last row here, and I'm going to type in date. We're going to create a new attribute called date, and we're just going to leave it as a string. That's fine. We're just going to have a string date here. So once you've done that, your table should look like this. We've gotten rid of the underscores, and we've added a date attribute. Give everyone a moment to make sure their dialog looks like that. Once you see that, you can go ahead and click OK. Now the triangles next to the port names we edited are changed to red. They're no longer connected to our source data. These triangles are called ports. When they're on the left side, like here, they're called an input port. When on the right side, like on your reader feature type, they're called output ports. Over here, the output ports have changed to yellow. Colors just help you do schema mapping. Green means it's connected. Yellow means it's a reader feature type that isn't getting written out anywhere. And red means it's on a writer feature type, but it's not receiving any data. So we've gotten part of the way there. Let's go ahead and save our workspace. I'm going to do a file save as and update, make a new version here called exercise 2.4 and save that. Again, you can save wherever you like, so somewhere you'll remember. Now what we're going to do is we're going to add a transformer to map our schema. Remember, a transformer is just a tool that you can use to modify your data in some way. So I'll show you how to add one. If we click this dark black line here to select it, and it will be highlighted in blue, that's called a feature connection line, and it will just control how the features move through our workspace. Right now, it's very simple, just move from the reader to the writer. We're going to add a transformer along that connection line so the features will be modified before they're written. Once you have that selected and it's highlighted in blue, you can just start to type the phrase attribute manager, which is the name of the transformer we want to use. So if you have that selected and you start to type, you'll see this window comes up. This is called the quick add window, and it lets you search for objects to add to the workspace. If you just type in part of attribute, you'll see we have quite a lot of attribute transformers. So you might want to go ahead and finish and type in more of it until you see the attribute manager appear. You can see a little section here that tells you what they do. This can alter attributes by adding, rename, copying, deleting, and reordering attributes. Once you have that, you can double click it or hit enter to add it to the canvas. So now you can see, because we had that feature connection line selected, it automatically gets added along that line. And now you can move things around if you want to clean up your workspace a little bit. I'm just going to make it a little tighter by moving these closer together. But that looks pretty good to me. So we've got our attribute manager in between our two feature types. Now we're going to set parameters on our transformer here, the attribute manager, to map our schema. To do that, you can double click the attribute manager. You might need to resize it a little bit. You can do that in the bottom right if you want to make it a little bit bigger. And you can see what we have here is 4 columns: input attribute, output attribute, which you can edit to change the name of attributes, attribute value, which you can edit to set values for attributes, and action, which will basically summarize what you're doing in the other columns. So what we'll do, if you scroll down, you'll see right now the input attribute case underscore type is going out to an attribute case underscore type. But what we can do is we can edit that. So click where it's underscore type, case underscore type in the output attribute column, and edit that. And you'll actually see that it does get selected from a dropdown. This is going to search your writer schema to find a matching attribute. So we can select that. And so now what's going to happen is it's going to map all the values from case underscore type onto an attribute called case space type. So then it will be mapped when it's written. It will actually appear in our written data. And you can even do that with a drop-down menu. This will show all of the attributes on the writer feature type. So if you scroll down, you'll actually see there's 100 block with a space, so I can select that. You can do the same thing with that drop-down for street name. Same thing for local area. And so now we have these mapped. So we're telling FME, take the data from the underscore attributes and put it into attributes with spaces. And you should see also the action column changes to rename. So once you have a dialog like that, you've mapped your underscore attributes to ones with spaces, click OK. And now you'll see those ports on your writer feature type turn green because they are now receiving data because we've changed what the attributes are named in the workflow. We still have a red input port on our date attribute on the writer feature type, so let's fix that. We want to add a new attribute called date. There's a lot of ways you could do this, but we're going to keep it efficient. Just do it all in the attribute manager. Open that up again by double clicking it. And then if you scroll down to the bottom, you see there's a blank row there at the bottom, and it has add new attribute written in it. You can click where it says add new attribute and type in date, which will also appear in the dropdown because it is on our output schema. So you can click that, and that will add a new attribute called date. We could set a value in here, but we're going to wait and do that in a later exercise. For now, we're just going to add a new attribute called date. It's going to be blank. And we can do that like this. So you should have output attribute date, and the action should be set value. And now once you click OK, you'll see that date also turns green. In this case, it is just receiving a blank value. It's just a blank string, but it does exist at least. There is an attribute called date, and so it's going to turn green. So let's save the workspace and then run. If you hover over the run workspace button, you will notice feature caching is kicking in here. It's going to use that cache from my red data, my source data, and then run the attribute manager and then run the writer. So if I click run, it will just use this cache, which you can see is a lot faster because the main reason our workspace was slow the first time is because we were reading all that data off the web. We only have to do that once. Now we have a cache. We can just keep using that. So now the data has run. If you click your attribute manager, that table will automatically be displayed down here in Visual Preview. And if you scroll over to the right, you'll see that our schema has been successfully updated. We have spaces now instead of underscores in the data, and we have a new blank column called date. So there you go. You've learned how to edit and map a schema, and we've added our first transformer, the attribute manager. That's one of the most commonly used transformers, so it's a good place to start. Okay, let's wrap up this section by doing a quiz. I'll give everyone, let's say, 2 or so minutes. Go ahead and give that a try. And again, just for review purposes, we're not recording that. And then we will move on to the next section. So go ahead and take a couple minutes, fill out the FME translations quiz. I will send a link to that in the chat. Okay, we'll keep it moving. Hopefully everyone had a chance to try some of those questions. You can always come back and review those later if you want. I will also put up another poll. I'm curious how people did with that section, if you had time and the ability to complete all of the exercises. So I'll go ahead and launch that poll, just asking if you were able to complete exercises 2.1 through 2.4. Go ahead and answer truthfully. There's no grades here. I'm just curious. We do have a pretty quick pace for this course, so we can cover as much as possible in one morning, but we want to make sure we're not losing too many people. So please do go ahead and vote. Let us know how many of those, or if you were able to complete all of those exercises. Okay, I'll leave that up for one moment before introducing the next section. Thank you for everyone for voting. Looks like almost everyone is able to do it, so that's really good to see. Okay, great. Thanks for voting. Next section here, we're moving on to transformation. So in the previous section, we were looking at data translation, going from format A to format B, and data inspection, looking at the data. In this section, we're going to look at what data transformation means, the two basic types of data transformation, and how to handle it in Workbench. We'll discuss some common transformer categories, locate and add transformers, and set transformer parameters. Data transformation is FME's ability to change the structure, geometry, and attributes of your data. Basically, you take what you have and turn it into what you need. Speaking generally, data transformation can alter the structure or the content of data, or both together. If you're organizing, or if you're changing the structure of the data, you can think of that as reorganization. So that would be things like merging data, dividing data, reordering it, defining custom data structures. So you're not really changing the underlying data itself as much as just how it's structured. Transforming the content of data could be called revision or creation, and that's manipulating a feature's geometry or calculating new attribute values to transform content. So you can do either of these or both of these using FME. So let's talk about these transformers. You've seen them already, but what actually are they? They're similar in concept to the tools in our toolbox if you use Esri products. Each transformer does a specific geometric or attribute transformation or some other support function. Transformers typically have a number of parameters that can be set. You can open those by double-clicking them, just like with your feature types. and that's where you control how the transformer operates. Parameter buttons on the transformers are also color-coded. If they're blue, that means you've looked at it and it's good to go. If it's yellow, it means it's been added and has a default value that you haven't looked at yet, so you might want to check it out. And if it's red, it means there's at least one parameter for which FME does not have a default value, so you have to fill something in. So it's missing something, and you won't really be able to run your workspace until that's addressed. Transformers may have input and or output ports, and some transformers only have a single input port or a single output port. So that does tend to vary. So you can see an example here, the most basic, this example of a 2D forcer, which just forces 3D data into 2D. That has one input, one output, takes in 3D data, outputs 2D data. Some will have multiple, so a clipper, if you want to use sort of a geometric cookie cutter to clip out one object with another, you have to have a clipper and a clippee coming in, and then coming out, you get objects inside the clipped area, outside the clipped area, and those are rejected. For example, maybe they don't have geometry. And then some only have single ports. So the inspector transformer, which will just automatically show something in inspector when the features come in, or creator, which just kicks off a workspace, those only have single ports. Finally, you can view the attributes coming out of a transformer port by using a dropdown, just like on a feature type. So for example, in our existing workspace for Attribute Manager, I can drop down the output port there to see the attributes coming out, and you will see, for example, the change here. These attributes have underscores in the source. Once they come out of Attribute Manager, they no longer have those underscores. So that's sort of a way to keep track of your attributes as you build a workspace. Let's do exercise 3.1, adding a transformer. I've just sent out a link to that. Here we're going to use a filtering transformer to remove those missing values we identified earlier. We don't want those in the final data. So make sure you have Workbench running and have this workspace open where you have the Attribute Manager added. If you haven't caught up, you can open up the starting workspace. Exercise 3.1 begin. Give everyone a moment to make sure that they have that set up. Okay, hopefully everyone is ready to go. The first thing we're going to do is add a tester transformer. This is the most commonly used transformer, and it's used to filter out your data. So to do that, click a blank spot on your canvas somewhere, and then type in tester. This will search the list of transformers, come up with the tester. As you can see, it evaluates one or more tests on a feature and routes the feature according to the outcome of the test. Go ahead and double click on it to add it, and it will appear on your canvas. What we want to do is actually test our features before they go into the Attribute Manager. If you're doing filtering like this, where you're removing objects, obviously you want to do that earlier on in the workspace, get them out of there so you're not doing unnecessary work. So we want to add that before Attribute Manager. So in order to do that, I'm going to move some objects around a little bit so I have more room to work with. I'm going to click my Attribute Manager. I'm going to control click my writer feature types bookmark. So I have both of them selected. I'm just going to move them over to the right to make room for my tester, like that. And then to add a transformer to an existing feature connection line, remember last time we selected this and then added it? Instead, you can also drag them onto a line. So to do that, find your tester, click and drag to select it and move it around. And then as you move it up, you'll see, actually, let me zoom in a bit more. You'll see this little green arrow in the top left-hand side of the tester. That's what you want to mouse over a connection to connect it. So if I move up here, my connection line will turn green, and then I let go, and my tester is added. Let me show that one more time, because some new users do have trouble with that. Here's the tester. I'm going to add it to my connection line. I click and drag, move it up here, get that green arrow over the connection line until it turns green, and then it will be added. You can either just wait or you can let go to add it. So now you can see, it's a little tricky with the feature count, but you can see there, this is connected up in between these two objects. Now you see I've got a red parameter button. That means I need to set some settings on my tester, some parameters on my tester. So I'm going to double click that to open it and fill this out. The tester basically just does a series of clauses, and then the features either pass or fail. So they're just going to do some logical operations. If they pass, they'll continue. If they fail, we're just going to drop them. You can set up these clauses using a table. So you have a logic where you can specify nots or ors, ands. And then you have a left value, which will be a static value or the value of an attribute. You have an operator, which will be any of these operators, is equal to, is less than, is greater than. And then a right value, same thing, static value or an attribute. So what we'll do here is for the left value, we're gonna click in that cell. So click in the left value cell, find the little drop-down arrow, click that, and we're gonna use the attribute value for local area. So left value, attribute value, local area. So this is gonna, for each feature, it's gonna read what the local area is for that feature. And then for the operator, you can click the drop-down. You see we've got quite a lot here. We're going to use attribute has a value down at the bottom there. And so this will check to see, does this feature have a value for local area? If it does, it's going to send that feature out the passed port. If it does not, it will send it out the failed port. So click that, and then you should have your test set up like this. We don't need any of the other options for this clause. That's it. Very simple test. Click OK. So again, now features are going to come in one by one. Tester is going to look, okay, what's your local area? You have a value, great, you passed. Good job, you move on. Don't have a local area, you're out of here. You're failed, dropping you from the translation. Now let's test that and see if the results are as we expected. As you remember in the previous exercise, we identified there were about 4,000 missing missing values for a local area. And so let's see if we can, if that's the result we get here. That's what we would expect. So click your tester. We're just going to run to this. So this is going to take the cache of our source data, just run it through the tester. So click run to this. Give your translation a moment to do all those tests, and then you will see the result, which thankfully is as we expected. We've got 4,122 features with missing values. Those have failed. They're going to be just dropped, and then the past ones will continue. Let me know if you have any questions. Looks like everyone's chugging along okay, so I'll keep moving. Next section here, next step, what we're going to do is use the text editor in FME. Remember we added that date attribute in the attribute manager? Well, it still doesn't have a value. We need to give it one. And so to do that, we're going to use the text editor. Double click attribute manager to open it up, and then scroll down to your date value or date attribute. You'll notice we have this attribute value column. So in here, you can specify what to set date equal to for every feature that comes through. So I could, type in January 1, 2000 and click OK. And just to show you, that's not what we want though. That's going to give every feature a static value. And so if I end up inspecting it, you'll see every date will be set to January 1st, 2000, which isn't really what we want. Right? If I scroll over January 1st, 2000, no, that's not what we want. So you could do that in some cases, if you were setting it equal to something that might be the case, you want to have a static value that's the same for all features. But instead, what we want to do is click this drop-down arrow and use the text editor. So open your text editor. This is what that looks like. This basically just lets you construct a string value. You can do it by typing in whatever you want. You can add the values of attributes. You can do string functions, so things like the leftmost characters, the rightmost characters. You can do replace, you can do regex. There's all sorts of stuff you can do with strings, and you can do that all in the text editor here. So what we're going to do is construct a date using these feature attributes. There's also an arithmetic editor, which has similar functions and lets you do mathematical calculations. For the date attribute, step 6 here, let's combine the existing attributes to give date some values. In the left-hand panel here, you have the heading FME feature attributes. Make sure you click that to expand it. You'll see a list of all of our attributes. First thing to do, double click this attribute year. So you can see what happens then is this adds a at value parentheses year to our text editor. And that's just the sort of shorthand for this will put in the value for year here. Now we're going to continue the process here. We're going to construct a string to have a very simple year, month, date format happen, year, month, day, I should say. And so to do that, we've got @value_year, put in a /. You can just type that in like that. And then we'll do month, and then /, and we'll do day. So you should have a value that looks like this. Alternatively, there's also a section in the manual you can copy and paste that in. And this is a case where in FME, if you want, you might do this often enough, you would learn, what to type in, and you can type it in manually. But to avoid error and just for simplicity, you can usually just use these to construct your string. Once that looks good, go ahead and click OK. And click OK again. And then use run to this on the attribute manager. That's going to construct our date value. So now instead of that static value that was the same for every feature that I showed earlier, January 1st, 2000, now we will have the actual date as a concatenated string. And so you can see that here. It looks like they might all be the same, but that's because, remember, this is in chronological order right now. It's sorted chronologically, but if you scroll down, you'll see we have actually constructed the date value. So there you go. That's how you can use a tester to filter out objects or features, and the text editor to concatenate and create custom strings based on other attributes. There's an advanced exercise if you want to check it out later. It shows you how to do a more advanced text editor function here to get the standard FME date timestamp. But we're not going to cover that. It's a little out of the scope for today. Next up, we're going to talk about using locating transformers. I noticed we did have a few questions. I'll just quickly tackle one of those, which was what programming language is used in the text editor. That primarily uses TCL, or some people call it Tickle programming language. So you will see that show up in a few places in FME. Again, though, really all of this is set up so you don't have to know how to code with anything or learn any new languages. Everything can be point and click if you want it to be. So one of the things that kind of throws new users of FME off is that there are a lot of transformers. If you look at the transformer gallery right now, under all, there's 492. So it's quite a lot of transformers. It can be a little daunting, but what we'll do in this section is show you how to just get the transformer you need and how to learn as well where to find the transformers that you want. Although that list is a bit overwhelming, keep in mind most FME users, once they have their kind of niche, their projects they're working on, they'll usually have, 20 or 30 transformers that are relevant to their day-to-day workflow that they use most often. They'll learn those, that'll take up most of their time. And then they'll develop skills to search for new transformers they might need every now and then. And that's what we're gonna try to focus on today. How do you find transformers when you need them? So there's a few ways to do that. One way is just using quick add to search. So if I just click on a blank part of my canvas and start typing, if I want to do a clip operation, a common geometric operation, I could type in clip, and then there we go, I'd find the clipper. And you can read the help here to see what it actually does. You can click the Browse Additional Help button to open up the FME documentation. All of our transformers have pretty extensive documentation with a full explanation of how they work. They usually have some diagrams to help explain it, related transformers, reference, all sorts of stuff. So that's really deep documentation if you need to answer questions when you're looking for a transformer. One thing to keep in mind though, if you are searching quick add, is that by default, it's only looking at transformer names. So the search term has to be the actual name of a transformer. If I search clipping, that's not going to do it. But if I hit tab, that changes my search mode. And then now I'll be searching the full text of the help as well. And so that would come up with the clipper, plus some other ones that might have implications for clipping. So that's something to keep in mind. You can change your search mode in quick add. Additionally, quick add includes aliases. So sometimes we rename or deprecate transformers. And so those will be aliased. So for example, there used to be an HTTP deleter transformer. Now, if I hover over that, that's just an alias for HTTP caller now. That's one transformer, does all those operations. So that will happen in there. And finally, there's the option to search camel case for transformer names. So some of our transformer names do it a bit long. So instead of typing in raster cell value rounder, it's a bit of a mouthful, you can just type in RCVR, the sort of initialism or camel case letters of the transformer. So that's one way to find transformers, searching in Quick Add. Another one is a transformer gallery. You can search in here as well. This will by default search the text of the help as well, so you can find, so clipping will show, will show all of those related transformers in your search results there. Wouldn't recommend just browsing all, that's a bit too much, but browsing categorized is really useful. So if you're working a lot with, for example, point clouds, we have 28 transformers to do with point clouds, so you can check them out in that category. You know, strings, we've got 43, etc. So that's a bit more of a narrower way to start reading through to see if that transformer will do what you want. You can also access the transformer gallery online at safe.com/transformers. This is basically the same as what you have over here. The only difference is you do have a sort by most used option, which is quite helpful when you're getting started. If you just want to know what the really popular transformers are, you can sort by most used and see two of the transformers we've already used, tester and attribute manager. They're right up at the top. Finally, there's the FME Hub, which I'd like to introduce. This is hub.safe.com. And this is where users can upload their own custom transformers, templates, web connections, and formats. And you can quickly add them to your workflow. So you can search for things on here. So if any of you work with raster data, for example, there's a custom transformer NDVI calculator. This will let you calculate the normalized difference vegetation index. So someone has made this and uploaded it for you to use. You can also find hub items by searching in Quick Add. So if I do NDVI, you actually will see this is searching the hub for custom transformers. If I were to select this now, it'll just automatically download it from the hub and add it to my workspace. That can be really good for very domain-specific operations. If you're working in something like oil and gas or linear referencing system, some people have uploaded some really specific transformers to do things that are common in that industry, and you can just grab those from the hub. So in the last exercise, we found that there were some inconsistent values for that local area attribute with or without a dash. So in this exercise, we're going to go through a process of looking for a transformer to address that problem. So this will give you an example of how to search for a transformer if you don't know what it is. I'm going to chat out the link to this exercise. The challenge here is we want to find specific text strings and replace them with another value. So we want to find, you know, the value with a space, replace it with one with a dash. That will match the City of Vancouver specifications. And we can use Transformer Gallery in Workbench or online. The FME Transformer Reference Guide, which is a big PDF, which is useful, has all the transformers in it, or Quick Add to search for a transformer. So let's start by going to the Transformer Gallery. I'm just going to pop that out into a separate window here. And let's see if we can find it this way. So, okay, we have a sort of a find and replace string operation. Where might that live? What category might that transformer be under? I think it might be under attributes. So I'm going to go to attributes because I'm trying to modify an attribute and select that. So that's a good start, but there are still 30 transformers in this category. We could go one by one and read each description, but that'll take too long. So instead, let's search for some keywords. We can try searching for find, right? We're doing a find and replace. Okay, find didn't come up with anything. What about replace? That didn't come up with anything. So that didn't yield anything. Those keywords would probably be in the transformer we're looking for. So maybe it's not under attributes. So it could be in a different category. Maybe let's try the strings category instead, right? We are working with strings here. We're doing a find and replace, so that might help us. This one has even more transformers. It's got 43, so we don't really want to search through all of those. So let's try those keywords again. If I do find, I get one called list searcher, which searches a list to find a value and returns the index of that value in the list. That doesn't sound right. What about replace? This gets us 3 transformers: string replacer, string pair replacer, character code replacer. If you read the descriptions here, it does sound like either of the first 2 will work. String replacer replaces substrings matching a string or regular expression in the string contained in the source attribute. String pair replacer does the same thing based on replacement key value pairs. So it actually sounds like either one of those would work. I'm a bit of an experienced FME user, so I know that string replacer in this case will be more straightforward, so we can use that transformer. I've got a little section here where the FME Lizard's giving a tip, which is worth pointing out. Again, there are often multiple ways to solve a problem in FME. You could accomplish the same result in this exercise by using any of these transformers here, some of them in combination, some of them with conditional values, which is a special technique. But as you can see, there's a lot of ways to do this. And we put in a little challenge in the training. If you find another way to do it, let us know at train@safe.com. But what that's to say is there's a lot of ways to approach a problem in FME. We're just going to show you one straightforward way in this case. So now that we found the string replacer, let's add those to our workspace. I'm going to close the gallery here. Make sure you have your exercise from the previous section open, or open up the 3.2 begin workspace. We're going to add string replacers here. So I want this actually to happen after the attribute manager. So I'm going to move my writer feature type over to make some room. Click that feature connection line between the attribute manager and 311 requests and type in string replacer. Once you have that, hit enter. That will add it to your canvas. So again, you should have a string replacer between the attribute manager and 311 requests. Once it's added, double click it to open its parameters. We can see what we can do here. So we have to pick attributes to modify. We're going to replace text. We're not going to be case sensitive. And then we just get to put in what's the text I want to replace and what is the replacement text. Pretty straightforward. This is basically if you use like Microsoft Word or something, find and replace. So for this, for attributes, you can double click that. This will give us a pick from a list. We'll pick local area and hit OK. So you should now have local area as the attribute. That's the one we're looking to replace values for. And then for text to replace, I'm going to type in arbutus space ridge, which you can copy from the manual if you don't want to worry about spelling. And then for replacement text, I'm going to do arbutus dash ridge. So your dialog should look like that. You've got for attributes, local area, text to replace arbutus space ridge, replacement text arbutus dash ridge. Once you have that finished, click OK. And you'll notice that transformer worked, but it only was able to do one replacement at a time. So we do have to add a second string replacer. You could just add a second one and fill it in again, but what's easier is if you right-click string replacer and select wherever it went, there it is up at the top there, duplicate. So that will keep the same parameters so we can do a little bit less work. So you should now have a string replacer _2 on your canvas. I'm going to move my writer feature type over even more. And then remember, using that click and drag technique, click and drag your string replacer 2, get that green triangle over the feature connection line, and let go to add it. So now you should have a string replacer 2 after your first string replacer. Double click string replacer 2 to open it. And now we just need to change the values of text to replace and replacement text. So you can go ahead and enter those in as shown in the manual. That is Dunbar space Southlands, and replacement text is Dunbar dash Southlands. Again, if you're worried about spelling or want to make sure you get it right, you can copy and paste from the manual. Once you have those filled in, go ahead and click OK. we should save our workspace regularly. So I'm going to do a file save as and call this exercise 3.2. Now let's select string replacement _2 and select run to this. And we will let our features run through and we'll see if our string replacers did what we expected. And again, remember we're using that partial runs, feature caching, and visual preview to quickly just build one section of the workspace and immediately test to see if it worked. That will save you the problem of hunting down errors later on if you don't get the result you expected. So once that runs, you'll see your visual preview will open. It will quickly index because it's a pretty big table now. And then you can search the values. So if we compare, you can now go and search our Butis space ridge and you'll get 0 results. Whereas if you put a dash in there, you should get 2000 something. And same for Dunbar space, Southlands has 0 results, Dunbar dash Southlands has 4000. So there you can see we use those 2 string replacers to fix inconsistency in the naming convention of our data. Someone's asking if you can do a more general find and replace. So, find a space and replace with a dash. That's a great point. You definitely can. You can also use regular expressions if you're familiar with those. I really like them. I'm not very good at writing them, but once you write it and it works, it's really nice. So you can do more complicated replacements using regular expressions. So that's that exercise. We looked at finding transformers and adding them to our workspace. I'll talk a little bit now about some common transformations. I see we're running a little behind schedule maybe, so I won't spend too much time here. This is a good reference though to come back and look at as you learn FME. I have a list of the top 30 transformers updated in March, so it should be pretty accurate. And if you take a look through these, you can see some things come out. It's very common for filtering transformers, so the tester or the test filter. Attribute transformers, attribute creator, manager, keeper, renamer. There's some geometric ones, the clipper, aggregator, reprojector, spatial filter. And there's some ones that are specifically for joining features together. So you've got feature merger. I believe there was another one, feature joiner. So you've got, those are some of the big categories. And so I've kind of, in the manual here, we've kind of explained some of the big categories that are worth thinking about. First would be managing attributes, such as, and those are usually named attribute something. For filtering, those are usually named something filter. That's where you can apply conditions to filter out features or send them to different areas. Data joins are kind of the opposite to filter. You're bringing together 2 streams of data based on a key value. So those are some of the big categories. And so that's just kind of a bit of a primer on what common transformers are. It's worth looking through this list of top 30 to get an idea of what all of them do, because there's a very good chance you will need to use them in your workflows. Finally, I'll just make the point that FME is broad. It's a pretty big piece of software. We have a lot of transformers. Don't worry if you can't find all the transformers you want immediately. The skills outlined here should help you find them eventually. And if you're still having trouble, we have a lot of resources to help you find the transformers you need outlined below, and I'll also go over those at the end of the day. So let's put those new skills to use and have you go on a little transformer hunt. I'm going to send out a link to exercise 3.3a here. Unsurprisingly, your manager has more requests for your workspace now that they've seen the power of FME. They want you to they're going to send you an Excel summary table of the 311 requests. So that data we're working with right now, they're going to summarize that by local area. So they'll count the number of calls, 311 calls, by department, by local area. So they have a summary table. And they're also going to send you a KML file of the local planning areas. They want you to join that data together. And so we're going to look for a transformer to join the summary table, which has, and the mapping data, which have a shared key value of local area. They both contain a local area attribute. So using the resources available, the transformer gallery in Workbench, the one online, the reference guide, and quick add, I'm going to give everyone a few minutes. Go try and find a transformer to join two streams of features, and then we'll go through the steps to add it. If you're not familiar with what a join is, there's a link to Wikipedia here to explain it, common database idea. So go ahead and try that out. If you want hints, you can click these hints here to expand them and to get a little clue. And I'll give everyone a couple minutes here to try to find the correct transformer. So you can read the description again if you need a little more detail, but basically you're trying to find a transformer to join two streams of data based on a common key. Go ahead and look for it. Okay, so that was a little bit of time. Let's take a look at these hints if you haven't found it yet. So it's in the filters and joins category. That makes sense. We're doing a join. It has a joiner in the name. Also good to know. So one thing to point out, there are several transformers that would work for this case, but we want an SQL style join. And finally, you might have found the feature merger or database joiner, which could be used here, but we're looking for one that works a little bit better. So let's go to next exercise for the answer. And the result is the feature joiner. As I said, there are quite a few other ones that might have worked, but this is the one that worked best in this case. So let's go ahead and I'll do a quick poll here. Were you able to find the feature joiner? Again, no grade, just curious what you ran into. It could very well be the case you found the feature merger or database merger or inline querier, but which would still work. They're just maybe slightly more complicated to use in this case. The feature joiner also does have the advantage of often being faster than the other solutions, depending on the use case, but it is often faster. So I'll let everyone vote and we'll see how many people were able to find the feature joiner. Please go ahead and do that if you haven't yet. Okay, thank you for voting. Looks like about 85% of people were able to find it. That's a pretty good result. I've just sent out the message for the next section. We're doing 3.3b here. Let's go ahead and do this where we're going to actually add the feature joiner. Pretty straightforward. We're not even going to fill it out yet, so this will be pretty quick. Make sure you have your exercise from the previous section open. And we're going to add a feature joiner. So type in feature joiner, hit enter. You might already have one from your searches. And then we're just going to put it where we want it for later. So let's just move it up above the string replacer here. We're actually just going to leave it like that, unfilled out, because if you can see, the planning department said they're going to send us Excel data and the KML data. We don't actually have that yet, so we'll have to wait until we get that. But we found the transformer we're going to need. So once you have that there, you can go ahead and save. I'm going to do a file save as 3.3b, save that. So congrats, seems like most people were able to find that transformer. Hopefully those of you who weren't found something similar or would be able to find it after some more searching. Go ahead and send out a quiz, give everyone a few minutes to do that. This does have slightly more questions. Don't worry if you don't get all of them done. I'll just give you a minute to try a few of them, and then we'll keep it moving. You can always come back and review this in the end, but we do have that one workflow section left to complete. So please go ahead and try that quiz out for a few minutes, and then we'll keep moving. If you want to get to the workflow section, you can always come back and try this quiz out again later if you weren't able to answer everything. So let's do this last section here. We'll finish up as much as we can. I'll definitely get you out the door at noon. The final exercise is somewhat optional, so if we don't have time to address it, that's okay. So this last section here, we're going to talk about workflows. The previous sections we covered data translation, remember translating between formats, transformation, what we just did, changing the structure or content of data. And we were working with relatively straightforward workflows where it's just sort of one reader, one writer, maybe some transformers. But as you use FME more, you'll run into more complex workflows where you're reading and writing multiple formats with multiple transformations along the way. So here what we'll do is look at how do you set up a workflow to do something like that. So just to talk a little bit about how you can set up your workflow. It's unlikely that you can do transformation with single transformer. So usually you'll chain together a number. So it's important to think about the order that you're doing that in. That's how most workflows in FME are constructed, chained transformers in series. But you can also do transformers in parallel. Sometimes you want to create duplicate copies of your features, do separate transformations on them in different streams. And so that's transformers in parallel. Keep in mind when you split a transformer, so when you have two feature connection lines coming out of it, you're creating copies. You're not halving it or anything like that, you're creating copies. And so sometimes you'll set up multiple streams like this. So here we have an attribute renamer. It's got 8 features coming out of each feature connection line, so it's copies. They're all going into separate transformers, and then they're actually being merged back together and written out in the library's feature type here. So it's easy to create a multiple stream. You just click and drag out to create new feature connection lines. Bringing together multiple streams is the same deal. You just bring them into the same port. The thing to keep in mind is that this operation is a union. So this is accumulating features. So here, in this case, the attribute renamer, we started with 8 features, sent them in 3 different directions. When we came back, we actually were writing 12 features. So we have accumulated features here. If you wanted to somehow smartly combine them back together so that they kept that same number of 8, but maybe with some new attributes, then you have to do a join, right? Which would be like an intersection, basically. So that's important to keep in mind. When you bring together multiple streams, you are accumulating in FME. And finally, here you can add multiple readers and writers. You're not constricted, of course, to a single format, so you can always have multiple readers and writers in one workflow. And this is where the power of FME really shines. You can be working with a lot of different formats to integrate your data. You can add a reader and writer in a couple ways. You can just add one with quick add. So I could type in PostGIS, add a PostGIS database, reader or writer. Or I can use the menu, reader, add reader, writer, add writer. Once you add that, it just opens up your expected dialog with a add reader. Removing a reader or writer, you can either delete all of its feature types on the canvas, or you can remove them via the reader and writers menu. You can update a reader or writer if it's updated in a new version of FME and you're working with an older workspace. Sometimes that gives you performance boosts. And finally, you can work with multiple feature types. So I already mentioned that feature type selection menu when you add a reader. Sometimes you can pick how many feature types you want to bring in. So that's one way to work with multiple feature types. You can also add them later on. For readers, you can import feature types. So you can add feature types from the reader that you don't have on your workspace yet. Or for writers, you can add feature types. So that will let you add additional feature types, layers or tables within a single writer. So for example, if you're working with an Excel, you'd add an Excel writer, and then each feature type that belonged to that writer would write out a new sheet in the workbook. Readers and writers have parameters. So if you're adding a reader, there's a parameters button here. This lets you specify how you want to read the data. And of course, that'll vary by format. We have a lot of different options for each format. You can also change those in the navigator section under parameters. The thing to keep in mind is with readers, some of those parameters affect how the data is read initially and how it comes into the workspace. For example, what feature types you get. And so some of those parameters can only be set when you're adding the reader. After they're added, you can edit them. Whereas some of them you can edit after the fact. And you can do the same thing with writers. We're not really going to get into that, but you have writer parameters as well that you can use. So for example, you can change the delimiter type for a CSV. In exercise 4.1, let's build out our workspace a bit, and we're going to work with multiple readers, writers, and feature types. So kind of get closer to what a regular, slightly more complex workflow might look like in FME. So as we saw in the last exercise, make sure you have that open. We have a feature joiner, but we don't have the data yet that we wanted to join. So let's do that as a first step. Let's get more data into our workspace. Remember, the planning department is providing a CSV summary table and a KML mapping file. So we're going to use both of those. First off, let's add a CSV reader. You can go to Readers, Add Reader. And then in here for the format, we're going to type in CSV and select that. And then for the data set, click the ellipses button. We're going to browse to C, FME Data 2019. We're actually going to go to Resources, 311, 311 Summary. So this is that Excel file that has been provided to you with a summary table. So your dialog should look like that. Click OK to add it, and that feature type will appear on our canvas. I'm going to put it over there above my other reader feature type. Now let's inspect that real quick. I'm going to click this inspect source data here. And if you do that, you'll see, this looks like our data is kind of messed up actually. It doesn't look like the columns have been divided properly. So that didn't work. What could we change to make that work? Well, that would be reader parameters. So if you ever read in data and it doesn't look like you expect, you need to take a look at your reader parameters. So what I'm going to do is delete this CSV feature type. It'll prompt me, you're deleting the last feature type of this reader. Do you also want to delete the reader? And I do. So I'll click yes. Let's try that again. Readers, add reader. Should remember all the same settings. But that didn't work. So let's hit parameters here and see what went wrong. This will give us a preview of how the data is split up. This is not correct. It's not separating it by comma. And then you'll actually notice delimiter character was auto. There must be some funny quotes or spaces or something happening in our data. Maybe it was even those spaces we added in to the column headers. So it didn't read it properly. So what we can do is we can change delimiter character to a comma. So just type in comma for delimiter character, and you'll see that will fix it. So once you have a comma in for your delimiter character, click OK, and click OK again to add your CSV reader feature type. Now, if you are to just run that and inspect it, you'll see the data is displaying properly. So again, if you ever run into a problem like that, it's probably because your reader parameters need to be edited. Next, let's add that KML reader so we can get our local areas data in. Click on your canvas and type in KML. Then for the readers, select Google KML. For the data set, click the ellipses button, and we're browsing to data, boundaries, local areas.kml. Don't need to change the parameters for this. Click OK. This will give us that select feature types menu I talked about. You can choose which feature types you want to bring in. We just want local areas region. Everything else is really just KML metadata and other KML sort of objects, which we don't need. So I'm going to hit this select all button to deselect everything. And then select local areas region. It's the only feature type we want. That should be the only one you have selected. And then click OK. Now we have a local areas region in here as well. And that's that KML. If you want, you can cache that, hit the run just this, and you'll see your results here. We've got those layers, that layer we saw earlier. Next up, we want to add a KML writer. So we'll do that by going to Writers, Add Writer. Format is going to be KML. This is what we're going to write out when we join our data. For the data set, we're going to put it in FME Data 2019, output, training, and then we actually get to name it here. So let's call it 311-local-areas. And then one thing we are going to change is we're going to change feature type definition to automatic. We don't really discuss this too much in the introductory training, but I have a link to the documentation if you're curious about that difference, but we just need to do that for this workflow. And then once we've done that, click OK. You'll be prompted to give this feature type a name. We'll just match the file name, which is 311 local areas. Type that in for the feature type name. And then click OK. I'm going to drag this over to the right of my feature joiner. So it looks like that. Then I'm also going to expand my writer feature type bookmark up there just to cover all of them. All right, these are both writer feature types. I'd like them to be in the same bookmark. Now let's connect everything up. So first we need to set up that feature joiner. We've got our, zoom out a bit, we've got our local areas region and our CSV, and those both need to be joined together. So we're going to send those to our feature joiner. And we can do that by clicking and dragging connection lines. Might be a little easier if you move your feature joiner over to the left. So I'm going to do that. I'm also going to expand my reader feature types bookmark a bit like this. And then all you do is you find the output port of your local area regions feature type, click and drag, and now you'll see you're dragging connection, and just drag it over to the left input port of your feature joiner. The CSV will go over to the right input port of the feature joiner. So you have those connected up like this. So you're bringing your left and your right table to be joined. If you open up your feature joiner, you'll see the options. We're going to use the default. This is just an inner join. For the join on, this is where we specify the common attribute. For left, it's going to be name, and for right, it's going to be local area. So this will do a SQL style inner join with the left and right table to join them together. So when you're finished, your parameters should look like this. Once you have that set up, click OK. And you can use run to this on the feature joiner to verify that the join worked as we expected. You will receive that unexpected input window potentially, but if you ever see that for this section, that's okay. So you see we have geometry on our features now. So these 22 features are polygons. But if we scroll over, we'll also see these are all those departments of the city. We have the number of cases for each department. So that join worked properly. We have 22 features. We've joined these data together. Now let's connect this up to our writer feature type. So click the joined output port here of your feature joiner and click and drag over to your KML writer and join that up. I'm going to collapse that. There's too many attribute names. Okay, so you see what we did there? We've got our data joined together in the feature joiner, and now we're writing it out to KML over here. So once you have that, click run to this on the 311 local areas, and that will write out your data to KML. You should get a translation was successful report in your translation log, and then you can open the containing folder to view the KML file. So we can take a look at this, and this should look like the output we had from our previous exercise 1.1. It might ask you if you want to reload the data, and you should say yes, because we want to definitely make sure we're viewing the version from the workspace we just created. And if you click a section, you should get the bubble as we saw earlier with the attributes located on it. So we successfully joined the summary table to the polygons. See a question in there, how do you know what to put as left and right? That doesn't really matter. That just depends on which features you consider more important, just based on SQL joins. So We're doing an inner join, so in that case, it's only going to take the matching records anyway, so it could actually be the reverse. It wouldn't affect it in this case. So there we go. We've joined those together. There's an advanced exercise here you can try out later if you want. This summary data here, this CSV, 311 summary.csv, you can actually create that using 3 transformers that are placed in your workspace over here. So you don't even need to read in anything different. So that advanced exercise, you can try that out if you want. It has some tips for how you might approach that problem. Okay, so we've got a little under 10 minutes now. And so I'd like to just talk about one more section here, which is best practices. I don't know if we'll have much time to do the exercise, but I should be able to introduce it and people can work on it if they like. We just like to do this best practice section at the end to give you an idea of how to organize your workspaces. Best practices means the best way of doing something. Of course, it might not be the same for everyone, but you can try to define them for yourself and for your organization. The main reason to use best practices with FME is it makes it easier for people to inherit your workspaces. That could be your colleague next week, or that could be you in a year. You might find this workspace and have to edit it and forget what you did. And that's where best practice comes in handy. It lets you easily document and understand what a workspace does. There's 2 primary ways you can style your workspace to make it easier to use. You can use annotation and bookmarks. Annotation lets you put a little comment on features. So for example, for my feature joiner here, I could right click it and say attach annotation. And then I could say join summary table to local area polygons. So I'm not just saying that this is a feature joiner, I'm saying what that feature joiner is actually doing. Maybe I could even say based on local area name. So you can add instructions and sort of comments. So basically like commenting your code if you do any programming. You want to be explaining what you're doing at each step so others can understand it. That's what's called attached annotation. If you have an object selected and you add it, you can also just add it to the canvas here and it shows up more like a post-it note. Maybe you could do a reminder to yourself for later, check this section, that sort of thing. And then bookmarks, we already have seen. There's these objects we have, the reader feature type and the writer feature type, these brown rectangles. These are ways of letting you organize your workspace. Once objects are inside them, you can move them around together like that. And these just let you put your workspace into sections. So I might, for example, select these 4 transformers and then right click and create bookmark. That will enclose all of them in a bookmark. And I might say clean up attributes. And so now I have a section there and I'm saying these 4 transformers, they all clean up attributes. And that just organizes your workspace into sections, makes it easy to kind of conceptualize what you're doing, break it up, and also for other people to see how the transformers relate to one another. Those are the basics of styling your workspace so other people can understand it. You can also resize bookmarks, as I showed earlier. And if you click the cog wheel, you can change some settings, you change the name or colors and that sort of thing. So we only have 5 minutes left. So what I'm going to do is I'm going to introduce the final exercise, exercise 4.2, parts A and B. I'll let you work on that after we wrap up. So before we actually work on it, I'll introduce it, and then I'm just going to do some housekeeping wrap up stuff before we finish at noon. So exercise 4.2 is, we have this final workspace, and it's a bit complicated. If you've added everything, it should look something like this. If someone came in out of nowhere and just saw this, they might not know really what it's doing. And so to help your colleagues that might open this workspace or yourself if later on, is you're going to go through and add some bookmarks and annotation to explain what the workspace is doing. So it gives you a list of 4 things to do: add bookmarks and annotations to the reader and writer feature types, add bookmarks to the transformation steps, add annotation to describe what the transformers are doing, and move around the objects like as you wish to make sure your workspace is nicely laid out. So I'm not going to go through those steps right now, but you can do that if you wish. The next exercise shows you the quote unquote answer, a good way to have organized your workspace. So I'm going to skip over that. You can give that a shot and then just compare your result to the sort of answer showed in 4.2b. Keeping in mind, of course, best practices are somewhat subjective. So you should just do the best you can, compare it to what we think is a good version of best practices. So there is a quiz. You can come back and do this later. It's just 3 questions. I'm going to move on and just do the wrap up here. Thanks for sticking with me today. It seems like we had some pretty good attendance. Hopefully everyone enjoyed learning a little bit about what FME can do. The first thing I'd like to do is just thank everyone. And if you could fill out this feedback form that I've just sent a link to on SurveyMonkey, that would really be great. This is the first time we've delivered this training for the new version of our software 2019. We've made some changes, so it would be good to see what people thought about it. If there were things that they liked or didn't like, please let us know on that feedback form. You should all get an email relatively soon, I believe by the end of the day tomorrow or the next day. You should get a certificate just verifying that you took this course. If you don't get that, please email us at train@safe.com. Here are some more resources to learn about FME. We deliver a lot of these live instructor-led training, so you can build on these. We're doing Desktop Basic next week. That will cover some of the same material, but in more depth over a longer period of time. Those are all recorded, so you can watch those on your own time if you want. Safe.com has all that information about our products. We have a very strong support team, so if you have, you can file cases with them or ask questions. We have a network of international partners, so if you're looking for consulting work, someone to help you figure out how to use FME in your organization, you can get in touch with our partners. My colleague Mark Ireland posts very often on the Safe Software blog with interesting ideas and tips and tricks for using FME. The documentation is the kind of very in-depth description of everything that goes on in FME, so you can check that out for more detail on any of the things we talked about today. The FME community, knowledge.safe.com, has forums where you can ask users questions, a knowledge base of authoritative tutorials that are smaller than this training, and in a place you can suggest ideas for the product. And finally, on YouTube, we have the FME YouTube channel where we post tutorials and other videos about FME.